like I said, although there's a fair amount of linear equation stuff on the test, you have to remember there are going to be things that are not linear equations on the test, things that are just related to parallel perpendicular lines, names of angle pairs, all that sort of stuff that we did from the first half of the chapter. That's going to be on the test too. And as you see, these reviews are basically practice tests. I mean, if you didn't notice the last time we took a quiz, that the review and the quiz were basically identical, just we changed numbers and letters, right?
Right.
Yeah. So it's probably a really, really, really good idea to not just go over this review as a group, but to then take it home and study it so you know what's going on, so that you're ready for the test. Because this is a test, not a quiz coming up. So, yeah. Oh. So what's that first thing we got going there? Line parallel to GC. So any line parallel to GC. Somebody tell me one line that you could answer. Yeah. DH would be parallel to GC, yeah. And just for the people who are maybe just watching on a podcast, let me just do this for you real quick. Our box looks something like this. Yay, I mean, okay. And GC is over here. And so DH would be here. Is there another line parallel to GC? What would it be? BF would work. AE. And AE with I here. Okay. So all of those would be parallel to GC. What would be a skew line to AD? Skew line to AD. There are a bunch of them. EF, BF. BF would work, EF would work. CG to AD, yep, that would work. Those are all skew, that's fine. How about perpendicular to FG? BF, EF, HG, CG, any of those would work. Again, watch the line symbol, okay? Actually, yeah, if so you want to name lines, use a line symbol. Intersection of plane CDH and ABC. ABC is the top. CDH is the right side. What's the intersection of the top and the right side? C is not the intersection. CD, what line? What CD? Line, yes, line CD.
Can you repeat that? I put it in my head.
Well, okay, you got the top of the box here, right?
Yep.
You got the right side of the box here. Where do they intersect? That line. Okay. Find the requested value and state the theorem you used to do it. So it's kind of double here. We have to find the value but state the theorem. The theorem is the name of the angle pair, right? Basically. So what would be the measure of angle 1? And I'll draw that up here for those watching. I'm not necessarily drawn to scale. Hold on, let me fix that. It's this way. Okay, so we have 87 degrees here, angle 1 here, and angle 2 here. What's the measure of angle 1? Y. What type of angle pair is that? You're going to get those flashcards out again, aren't we? What do we call that? Well, first off, is it interior, exterior? Are they both interior? Yes, they're both interior because they're in the inside, okay, between the parallel lines. So are they consecutive or alternate interior? Alternate. 81 and 1 are on alternate sides of the transversal, so alternate interior angles. Okay? Because they make what shape? Kind of a Z. All right? How about the measure of angle 2? What's that going to be? 93 degrees. Why? What kind of angle pair with 87? No. Consecutive interior. Clearly, we're going to have to check out those flashcards again. Okay, you had those names pretty much memorized for the last quiz, but you can't do short-term memory with the stuff we learn in geometry because we keep using it over and over again. Got to get this stuff permanently on the long-term memory. Next one looks like this. Transversal that way. We have 6x minus 11 and 37 degrees up here and 6x minus 11 down here. All right. So we need to find the value of x. How are we going to do that? What's the equation going to look like? Yeah.
6x minus 11 equals 37.
Sure. And we're going to have to justify it. So what's the name of that angle pair? That's corresponding. They're both in the same corresponding position, upper right, corresponding angles. By the way, we are told the lines are parallel. Last one, you see corresponding. And we got to solve that, so that's simple algebra. 6x equals 48, x equals 8. Okay, corresponding angles theorem. E-O-R-E-M. I can't spell today. Okay. So there we go. 7 and 8. This one does not ask you to justify. It just asks you what value of x makes the lines parallel. But it essentially works the same way. We had 4x minus 12 and 120. What are we going to do with those to solve? We're going to set them equal to each other?
No.
Would that even make sense? No, because this one's acute and this one's obtuse. Add them up to, so supplementary, add them up to 180. So 4x minus 12 plus 120 equals 180. Now we have to be careful. I'm still seeing this mistake far too often. Okay? And some of you are laughing at that, but seriously, I see that too often on quizzes because what are we doing? We're adding 12 to the same side twice. We're adding 24 over here and nothing over here. We're not in balance anymore. Okay? I want to combine the terms. The minus 12 and the plus 120, that gives me 4x plus 108 is 180. Then we subtract. So 4x is 72. And what is that? 72, 1, and 32, 18? Okay. Number 8. We had 3 times x minus 8, 3 parentheses x minus 8, and 2 parentheses x minus 10. Plus 10. Sorry, thank you. What type of angle pair is that, by the way? What's the name of that? Alternate exterior. They're coming back there now, aren't they? Okay. And what has to be true for the lines to be parallel? These two have to be equal, congruent. So 3x minus 8 equals 2x plus 10. Now we got some algebra to do. Make sure you're showing your work though, because again, if I see that set up like that, if I at least see that and you make a mistake in your algebra, you're probably at least at half credit already because you've shown me that you know what the relationship is. 3x minus what? 24 equals 2x plus 20. And then we can do just a little bit of algebra. And I get x equals 44. Okay. Wonderful. Determine which lines, if any, have to be parallel based on the picture. And the picture is not necessarily always drawn exactly like you think it would be. The lines may or may not be parallel based on the picture. But the information they give us here in the first one is they have a 120 and a 60. And the lines are L, M, N, and P. Okay. Okay, explain your, tell which lines are parallel, explain your reasoning. So you might have to use some angle pair names here to do that. Do I have any parallel lines in this picture? Yes, I do. Which ones? L, okay, so L is parallel to M because what? What's supplementary? You're right, something supplementary, what? Okay, but what do we call that angle pair? Nope, not corresponding interior. Interior is right. Consecutive interior, okay? I know it's easy to get all those C words mixed up, corresponding, consecutive, congruent, stuff like that, because consecutive interior angles are supplementary. Okay? So identifying the parallel lines is part of it, but the reason is certainly going to be there. If you don't give the reason, you're only getting half credit at best. Next one's a little more interesting. Picture's definitely more complex. And we got this line coming through like that. Yeesh. All right, let me grab this for a second. All right, so we're given that this is a right angle, and this is a right angle, and this is 120, and this is 120. Get my arrows in there and let's name L, M, N, P, and Q. L, M, N, P, and Q. All right. Complex picture, right? So what we're going to start doing is we want to start isolating. First off, I know that M isn't parallel to anything. That's pretty obvious. But M could be a transversal. Do I have anything, if I just look at line L, and the rest, don't look at the rest of the picture, which is hard to do with the smartboard, but you can cover it up on your sheet. So do that. Look at just line L. Is line L a transversal for any two lines that have to be parallel based on the fact that you see there? All I have is this right angle up here, right? And I cover everything else up. I don't have, can I do that? Hold on, let me try this for a second on the smartboard. Let's do a fill. Okay. So if I do this, and just look at that, okay, do I have any parallel lines based on what I see right there? No, because I only have the one right angle, that's not enough. Okay, what if, I can rearrange this box a little bit. Okay, let's move it up here. Let's just look there. Do I have any parallel lines there? Just that one right angle there, the 120 over here, but that doesn't help me at all. Okay, so let's look over here. Let's for a second just eliminate this line. Let's not look at that. Do you have any parallel lines? Which ones? P is parallel to Q because, what do we call that angle pair? Makes the Z. Alternate interior angles. are congruent. Okay? Bring this line back. It goes there. Okay? So P is parallel to Q. Do we get L is parallel to N at all? Sorry.
Yeah.
How?
Well, if you move the box.
It's interesting. Hit delete and it's still there. Okay. Do I get L parallel to N at all? Where's the common transversal that they're both perpendicular to? Because what?
Well, if there's a right angle, aren't they all right angles on the L1?
Yeah.
And then, yeah.
I don't know why it's doing this, but okay. Yeah, go ahead.
If those are all right angles, then
There we go.
N would be all right angles
Well, wait a minute. Why would N be all right angles?
because it's a right angle.
Right, but that doesn't. But these two aren't connected. There is a way you could get P parallel to N, and I probably wouldn't expect this, but since P is parallel to Q, that means now, since P is parallel to Q, that means that these corresponding angles have to be congruent. So that's the right angle. And then I could get L parallel to N. So I would have to say, and it'd be a very complicated explanation. I'd probably not expect you to find that second conclusion. And if you did say that L is parallel to N, you'd have to say because P is parallel to Q, so L is perpendicular to P and Q. Okay, and that now, and so Q is and then Q is also perpendicular to N. And these two make that. But that would be really complicated. That's a really complicated picture. Most people I would expect would get this. This, not so much. You might say L is parallel to N, but if you don't have the correct reasons listed afterwards, it wouldn't work. You have to give the reasons. So probably that if you came up with this one, I'd probably consider that like extra credit if you actually came up with the correct explanation there. Because that's pretty hard. You're making several steps of conclusion. All right. Fill in the blanks. The slope of perpendicular lines are opposite reciprocals, negative reciprocals. If you're not sure how to say that in words, you could say n and negative 1 over n. Okay? So if you can't do it with words, do it with actual, like, variables. Slope of one is n, this other one is negative 1 over n. Or n. What? Numbers would be a specific example. They probably want a more, it'd probably be most credit if you gave correct numbers, but not full because we want a general case. Slopes of parallel lines are same. I take accept the same. The slope formula is m equals y2 minus y1 over, okay, and this will not be up on the board, so sorry. Okay. The slope of a line of undefined, the slope of a perpendicular line will be, undefined slope is what type of a line? They're all straight lines. Remember, no. Okay? Remember, most slopes are lines that have angles like this, but we have two special cases. We have the horizontal line and the vertical line. Okay? The horizontal line, the slope equals 0. The vertical line, the slope is undefined. We talked about this in terms of skiing. Okay, cross-country skiing, skiing off a cliff. Okay, undefined slope, no ski slope, you're going to die. Cross-country skiing, perfectly safe, slope is 0. Okay, so if the slope of the line is undefined, the slope of a perpendicular line will be what? The slope, no, horizontal, so the slope will be 0. The slope of the line is 0, the slope of a perpendicular line will be undefined, right? Because the reciprocal of 0 is undefined. The shortest distance from any point to a line is a perpendicular line, or right angle line. Okay. So there's a little short answer there. Knowing your stuff. Finally, writing the equations of lines. Please pay attention to parallel or perpendicular. This is what we did yesterday. That's what we focused on yesterday. Notice there's no problems for finding there's no problems on here. It says find the distance from this point to this line. Okay? It's just writing equations of lines. But sometimes the equations are not in slope-intercept form. So y equals 1/3 x plus 1. Again, we use our point-slope form. Make sure you know that. You will need that for all these problems. For number 1, we got the point, 3, -2, so y plus 2, x minus 3. And the slope is going to have to be what? 1/3. And then we just finish. Remember to distribute this. Some people forget to do that. And then show your algebra, please, because this is algebra work. But show your steps. Don't just go straight to this conclusion. I need to see that point-slope form. If you can at least show me that, you got partial credit coming right away. Okay? Number 17, 3x plus 2y equals 18 is my parallel line. And what did we learn yesterday? That it's not the slope until it's in slope-intercept form, is it? The slope is not 2. The slope is not 3. The slope is not 18. It's not in slope-intercept form. We have to do what to get it slope-intercept? Subtract 3x. So 2y equals -3x plus 18. Now what? Divide by 2. So y equals -3 x plus 9. Which number am I interested in? The -3. Okay? So y minus, the y coordinate of this point is -5, so y plus 5 equals -3 x minus 2. Because the point is at 2, -5. And we just go ahead and continue doing our work there. In the interest of time, I'm going to keep moving on. Y equals 4x plus 1. And the point is -1, 3. But what do the instructions say for number 18? Perpendicular line. So the perpendicular slope is going to be -1/4. And now I proceed. Y minus 3 equals -1/4 x plus 1. Now, we do get a fraction here. We're going to have to add 3 to both sides. But 3 minus 1/4, that's actually something you probably don't need a calculator for, right? -1/4 plus 3. Well, 3 minus 1/4 would be 2 3/4, which is 11/4. You guys are looking at me like I just did magic. If you need your calculator, use it.
How did you get Dorn?
Distributing. You have to distribute. Yeah, you have to, that number slope you distribute over the parentheses. You do that every time. Just like when we did the same thing back here, we distributed the 1/3. Okay. And number 19 would be similar. Then determine which lines, if any, are parallel or perpendicular. And the way I'd be looking for on these is you're going to actually have to solve the equations for y, okay? You're going to have to go through and rearrange your equations. Some of them are already solved for y, some are not. But then I'm just going to expect to see for answers like either A is parallel to B, or A is perpendicular to B, or B is parallel to C, that type of thing. Okay, that's how I'm going to want you to list your answers. But again, you're going to have to do that based on the slopes of the lines. You have to solve the equations for y to get that to work out. Let's look at number 21. X minus 4y equals 8. Okay, it's supposed to be an 8. There we go. Solve it for y, so subtract the x. Negative 4y equals negative x plus 8. Divide by negative 4. Sorry. And negative 4's cancel. Y, negative over negative is positive. 1/4 x minus 2. So that's my first equation. That's line A. B is y equals 4x plus 1. That's given to us. We don't have to rearrange that one. Are these two parallel? Are they perpendicular? No, because they're both positive, so we're okay. We're not perpendicular. C is x plus 4y equals 2. So again, we have to solve this, subtract the x. 4y equals negative x plus 2. Divide by 4. So y equals negative 1/4 x plus 1/2. So C is y equals negative 1/4 x plus 1/2. So we had to rearrange all that. Now, are A and C parallel? No, positive 1/4, negative 1/4. Signs matter. Okay? Are B and C perpendicular? Yes, they are. That's the only conclusion I can make here. A is not parallel or perpendicular to B. A is not parallel or perpendicular to C. B is perpendicular to C. But we have to get all three equations in the same format before we can compare. All right. That's what's going to be on your test tomorrow. Actually, probably the hardest part is some of the complete the sentence stuff, fill in the blank. It's probably some of the toughest stuff on there. Obviously, you need to know your angle pair names, because that's going to be important for reasons. So study those flashcards. Anything else? I will put this review podcast. I will post this on my page. It's kind of long, but you can. If there's just a particular problem that you didn't understand, you can just zip through it to whatever problem you need to go over again, and you can just go over that again. I wouldn't necessarily recommend listening to the whole thing again. That would take a long time. But you've got opportunities now to look at the things you need to look at. All right.